I hope that you see it now.
Yes, we can see it, yes.
Okay, good morning from the University of Jordan in the capital Amman. I'm going to talk about artificial intelligence and machine learning applications. These technologies that are now very important and are responsible of much of the magic that we see today in recent technologies. I'll start with giving an introduction about artificial intelligence and machine learning. Then we'll have a look at the achievements of contemporary artificial intelligence, AI. And we also will look at the limitations of the contemporary AI. And I'll end by trying to forecast the AI future. Now, let's be specific about intelligence. Intelligence is the ability to accomplish complex goals. For example, you as students, you can achieve complex goals like graduating and getting a graduate degree. Artificial intelligence, AI, is the non-biological intelligence, the intelligence that we find in entities other than humans, like programs or machines. And usually artificial intelligence is something humans program in machines. Now, there is narrow intelligence, and narrow intelligence is the ability to accomplish a narrow set of goals. Specific things, like a machine that can play and win a chess game, or a machine that can drive a car, but not the other. A machine or a program or an algorithm that can win a chess game does not drive a car. So this is narrow intelligence. General intelligence, on the other hand, is the ability to accomplish virtually any goal, including learning. Humans have general intelligence. A baby can learn languages like Arabic, English, or Chinese, and can study different disciplines and drive cars, play football, and other things. Now, many large companies and researchers are currently investigating and trying to develop general AI. It is not there yet, but once it is reached, it's expected that we'll reach the artificial super intelligence soon, which is a general intelligence far beyond human level, much more intelligent than the smartest people on Earth. Now, most of the modern artificial intelligence magic comes from machine learning. Machine learning are those algorithms whose performance improve as they are exposed to more data. Like Facebook, you upload a photo, you tag yourself, Facebook becomes more and more able to recognize you in new images and new photos when you tag and upload more data, more images. And deep learning is a subset of machine learning that uses multiple layers of neural networks, maybe hundreds of layers. And usually such networks learn using huge data, thousands and thousands of examples. By going over thousands and thousands of examples, they learn complex things like recognizing people in photos, or translating from one language to another language. There are many machine learning types, and the most famous three types are supervised learning, where the machine learns by training on data that has the answer and the question and the answer. It's called labeled data. For example, you give Facebook photos that and you tag yourself. This is Muhammad, for example. On the other hand, there is unsupervised learning, where the machine takes unlabeled data and tries to get some insight of it. One way to handle unsupervised data is to sort it into clusters or groups of each group is similar and different than other groups. And I'll come to it later. The third type is reinforcement learning, where a machine learns to do things because we give it feedback, like learning how to play Atari games. A machine now can learn by reinforcement to play such games because we give it feedback, the score. Is it doing and winning or losing? When it tries and plays the games many times, it figures out how to win such games. This is a fast introduction about AI and machine learning. Now let's look at the achievements of contemporary artificial intelligence. I'll start with reviewing important AI milestones, starting with 1997, when IBM developed Deep Blue that was able to beat Garry Kasparov, the grandmaster of chess at that time. And IBM did it because Deep Blue is a fast, large parallel machine that can search many possible moves and select the best one among thousands and thousands of possible moves. It was a fast a program that has fast search algorithms. In 2006, Hinton and his colleagues were able to train a deep neural network, and that was an important milestone. Before 2006, people were able to train simple, shallow neural networks, and were not able to train deep neural networks that can answer tough questions like translating from one language to another question. In that year, Hinton and his colleagues were able to recognize handwritten digits from 0 to 9 by using a deep neural network. In fact, it is a network of one input layer. You give it the pixels of the photo, 3 hidden layers, and 1 output layer that gives you the answer. Is it 0 or 1, and so on. This was a big success, and from that time, people started to use deep neural networks to solve tough problems. In 2011, IBM developed another computer called Watson, which won the Jeopardy quiz show. This is an American quiz show where people are asked different, usually tough knowledge questions. And as you see, Watson was able to beat the best human competitors. Watson is a landmark, is a good milestone, because it can access large amount of data and knowledge from encyclopedias and Wikipedia, has language understanding capabilities. You give it a question in English, and it understands what is the required thing, and goes and finds the answer very fast. In 2015, deep learning was better than humans in recognizing image. There is a competition called ImageNet. This is large-scale visual recognition challenge where you must recognize objects of 1,000 different classes, like a dog, a person, a chair, and there is a large data set. You can train your network on 1.2 million images. This is enough for deep learning to get excellent results. And this chart shows how machine improved over time from 2010 to 2017 with deep neural networks, 8 layers, 22 layers, 152 layers. The error is decreasing. In 2015, the error was 4%, which is less than the human level. Humans score 5% error rate. The improvement kept going on, and in 2020, the best score is 1.3% only. Another thing, going back to reinforcement learning, DeepMind, which was bought by Google, developed AlphaGo, a machine learning program that can play the Go board game. And the Go board game is 19 by 19. It has many more options than chess, and you cannot solve it by search algorithm. But this is a strategy algorithm, and using reinforcement machine learning, DeepMind were able to beat the best player at that time from Korea, Lee Sedol. In 2017, Google was able to develop, it has a project called Waymo, and the Waymo reaches in 2017 a full self-driving capability. In fact, now in states like Arizona and California, you can order taxis that are from Waymo that have self-driving capabilities. Autonomous vehicles are safer than humans. Here, the low level is the machine, and the red one is the crash rate for humans as a function of the age. Inexperienced young people are usually have more accidents than mature ones. Of course, the autonomous vehicles have very great potential in reducing transportation rates and making our roads safer and insurance fees lower. So to sum up, what are the achievements of contemporary AI? AI recognizes our voices and photos. and even talk back to us. AI recommends who to friend in Facebook, for example, and what to watch on YouTube or Netflix, and what to read on Amazon. Helps us in searching and retrieving information on search engines like Google search, translate natural languages. Google Translate can translate between more than 40 natural languages. It can drive vehicles. It secures our cities' computer systems and detects violations. Also, it provides cheaper solutions with acceptable qualities. This is why people are using AI, because it gives us solutions that are cheaper than going to humans. For example, you can go to Google Translate, get a good enough translation. If you want to do it using a human translator, you will pay a lot of money. It provides trained models. People trains model and makes them available for others to use. So you can get now a model that recognizes Arabic or recognize different objects in a photo. Also allows us to allows transfer learning, where a model trained for one task, like recognizing general images, it can be retrained with fewer samples and with less time to solve another similar task, like recognizing things that you are interested in and have in your house, for example. Now, to the limitations. Limitations of contemporary AI. It is narrow AI. One program can solve a specific task. Deep learning requires huge data sets, thousands and thousands of examples. Deep learning takes long training times, sometimes weeks. The machine goes computing and training for weeks. And deep learning needs powerful processors and computation accelerators. For deep learning, you need powerful machines. This is, for example, one recent graphic processing unit from NVIDIA. It is used in machine learning, among other things, and it has a huge amount of computational cores. It has about 7,000 CUDA cores that can do computations in parallel. And this is possible because transistors now are very small, and we can put 54 billion transistors on one chip. Now to the last part, which is the AI future. Before predicting what's the future, let's answer the question, why AI is succeeding now. It's succeeding because there is data availability. We have data to train machines. We have improved machine learning algorithms like neural networks of different types, reinforcement learning, and others. We have now fast processors that can train deep network that has millions, maybe billions of parameters. These fast processors can train such machines in a reasonable time. And I think that AI will continue to succeed in the near future, because more data will be available for machine learning. Digital content doubles every 2 years, and this will continue to, because we'll have more smart home phones, more computers, more services. Better algorithms and AI applications will continue to develop. People are interested in these things, and it's expected that global AI software market will reach over $100 billion in 2025. And computers will continue to get faster. And this is happening from 70 years ago. Performance improves about 100 times every 10 years. This is a recent graph from top 500, the top 500 supercomputers. Over time, the performance increases exponentially. This is a log scale. And now the fastest computer is a Japanese. It has more than 8 million cores, and it can do about 400,000 tera floating point operation every seconds. Of course, this large supercomputer consumes a lot of power. It consumes about 28 megawatts, as much as a town consumes. To where we're heading, I think that we're heading, continued AI development will lead to something called singularity, which is the point in time when machines become faster than, smarter than humans. And from that point, most of the development, composing and inventions will be done by machines very fast, and we can we'll see very rapid change. Of course, there are many scenarios, some good ones and some bad ones about the singularity. When machines are smarter than humans, if they are aligned with our objectives, they will serve us to have better welfare. If they are not, or if they are controlled by some company or one country, they can misuse us or even eliminate us at all. This is the end of this talk. In summary, I've explained the artificial intelligence, machine learning, and deep learning. Narrow GI is available now. Narrow AI is available now, but people are trying to reach general artificial intelligence. There are great achievements for the contemporary artificial intelligence, but there are many limitations. People are working on them, and I hope that in the future we will get artificial super intelligence that serves the entire humanity. Thank you.
Okay, thank you, Professor Keith Abanda, for a very interesting talk. And I think you have highlighted so many concepts that I think we should also work on from now. We talked about how data is shaping the artificial intelligence, the ease of getting the data. And also you mentioned about the computational powers. And also this is something very vital. We talk about the VLSI and shrinking the computational, I will say, ICs, how they are also shaping the artificial intelligence arena at this time now. You also mentioned about a few topics. We talk about IBM Watson, and in fact, it is something that would like also maybe also we do a focus on at our College of Engineering, and also get some, I mean, advantage of the Watson. I will leave the floor for any question. If anybody would like to ask Professor Qais, please go ahead, and just make it short if you don't mind. And also at the same time, we don't want also repeated questions. So anyone would like to have any question or comments to Professor Qais, the floor is open right now.
Assalamu alaikum wa rahmatullahi wa barakatuh. This is Dr. Ayman Khazraji. Thank you, Dr. Ghaith, for this nice and informative presentation. And thank you also for the organizing committee for inviting such scholars like you. I just would like to know, in fact, to which extent we can rely on the artificial intelligence, given that we have a lot of ambiguity inside. There is no explainable model, because if we can get the decision, but I need also to know, as a doctor or as any specialist, why should I rely on this decision? It is unlike the analytical model. We have a clear explanation about modeling stability and so on. This is not really yet well established mathematical approach. Thank you very much.
Okay, thank you, Dr. Ayman. This is called explainable AI. An AI that we can explain, or we can know why it took a decision and why it gave that answer. This is important in many applications, like in the law, or in when driving a car and making an accident, and in medicine, as you have mentioned. People are working on that, and there are techniques that that give us some insight how the AI reached its answer. But I would come also to go back to one of the statements that I gave. People use AI even when it is not perfect. For example, I do research where I try to use artificial intelligence and machine learning to find a solution for the Arabic language. It's not perfect, but we can now diacritize, add short vowels, الحركات, on an Arabic text with accuracy that is about 98%. Yani we have one error in every 50 character, and this accuracy is good enough to most applications, for students, for new learners. Also, if you want to convert text to speech, when the text is that well diacritized, it will people will be able to read it or synthesize it very, very easily. This is the short answer for your question. Yes, explainable AI is important, but AI is used because it gives us good solutions, not perfect, but because it is cheap. Many of the AI services are free for us now.
Okay, thank you, Professor. There is another question from Professor Mahab you can make it shorter, please.
Okay, thank you, Professor Gheith. We really appreciate your contribution to this event. I know that you were so busy and you have a lecture before this time, and I really would like to thank you. Can you please elaborate on your, you mentioned previously that you have Erasmus Mundus project with Europe in artificial intelligence.
Yes.
And we would like to, if you can share with us this project. And
yes.
Also, my second question is, what application in the Middle East and in Bahrain and Gulf area you see that could fit for artificial intelligence with also your Arabic language applications? Yeah. So this is my question, and thanks.
Okay. We think that artificial intelligence and robotics are very important for all countries. And no country should be left behind. All countries should develop their capabilities in artificial intelligence and robotics, because people who master these excellent technologies can produce better and cheaper products and services. We thought that we should improve and develop the curricula in artificial intelligence and robotics. This is why we prepared a proposal to start a new project for developing new courses and new programs in artificial intelligence and robotics. And we got a generous grant from the European Union and its Erasmus Plus program. And this is a regional program where multiple universities from multiple countries, Arabic and European, cooperate together to develop the best curricula. For the Arabic language, there are a lot of problems that need solution. Some of them is to improve the language that people type or talk. Many people make spelling mistakes, have not precise or clear language, and we need tools that translates dialects and poor language full of errors into a proper Fusha, for example, and a clear language. This is a huge problem, but I think that deep learning is powerful enough to help us solve problems such like this one. I think for the region and the Gulf, AI now is the new electricity. It's going everywhere. No company or organization can afford to ignore AI. People expect to find AI in the services and the applications that you use. AI will enable cities to be safer and smarter. AI will enable companies and organizations to cooperate more effectively and personally with their customers. And AI will help industries to produce better products and services and find better ways to explore resources or to produce products.
Okay, yes. Thank you, Professor. Thank you, Professor Qais. In fact, I have very short, question here, if you don't mind. Can you tell us, Professor Qais, about the thesis work that you have been doing in Jordan? I mean, if it is fine with you to elaborate in topics that you think, I mean, our students might be also thinking about at this stage, especially, inshallah, and you are going to have a new batch also in 21-22 academic year.
Yeah.
Also, we are preparing ourselves at this stage. Can you please elaborate about the thesis work you think they are vital at this time?
Yes. In fact, yesterday, our department, the computer engineering department in the University of Jordan, we discussed 11 master's thesis proposals for master thesis, and 6 of them are students that I'm going to supervise. One of them is going to study how to make AI or machine learning faster, why it is slow, and how to make it faster when solving problems related to the Arabic language. Another one is going to study how to automatically correct mistakes in Arabic text. There are common spelling mistakes, and we'll try to find solutions how to correct these mistakes. One of them is going to study how to make machines say poems, Arabic poems, how machine says share. We hope that one time we'll be able to develop programs that enable one person to write or say what he feels in normal prose language, and the machine translate these ideas into share, into Arabic poetry. One student is working on recognizing handwritten Arabic documents and converting them into text, and this will help us convert old manuscripts into digital form. One student is going to study how to get the sentiment out of Arabic text, like things on Twitter or Facebook. What is the sentiment? Are they with or against? Are they angry or happy or relaxed? The final one is going to study how to develop a machine learning program given the photo of bacterial colony and recognize what type of bacteria is there, without the need for further, more expensive tests and experts. These are few things that we hope to work on in the near future.
Okay, thank you, Professor Qais, for sharing a few thoughts with us. And I am sure that through the coming days or maybe weeks, by the start of 21 January, we'll communicate with you to have some thoughts about maybe some concepts about thesis maybe. And also would like to have your thought about short courses, training short courses. And this is something that we would like to elaborate also with Professor Youssef also, that he was talking about the telecommunication networks, presentation. So I would like to take this opportunity to say thank you, Professor.
Yes. First, I'd like to thank you for inviting me, and I'm happy to have contact with my friend Dr. Mohab. I think you are doing an excellent thing. I think you're starting very important programs, and I wish you all the best and all success, and God bless you.